now. So the title of the talk is Top-Down and Bottom-Up Sources of Meaning in Silent Gesture. Chuck, you can start.
Great, thanks. So as Carlos said, my name is Chuck, and I'll be talking about top-down and bottom-up sources of meaning in silent gesture. So first, a little background. Gesture is the conscious or unconscious movement of the hands, often but not always accompanying speech, and often but not always communicative. So gesture occurring with speech, or co-speech gesture, is claimed to be parasitic on speech, in that it's reduced in form and in meaning. Further, co-speech gestures are claimed to not combine with each other into gesture strings. By contrast, silent gesture occurs when gesture takes on the full communicative load of an utterance, that is, without speech. As such, silent gestures have been argued to take on language-like properties, such as appearing like word-like units and being combined together into a consistent constituent order, or having a phrasal level syntax. But despite these language-like properties, many still claim that silent gestures represent events holistically. That is, there's no combinatorial structure at the sublexical level or below the level of syntax. The basis of this claim is from an off-cited example of co-speech gesture. In this example, a participant expresses in speech, Sylvester drops a bowling ball down a drain pipe, while making a dropping gesture with their hands. By argument, the dropping gesture is holistic, with pieces of meaning being identified by the speech. That is, the speech identifies the round hand shapes as referring to the bowling ball, and the dropping motion as referring to the dropping of the bowling ball. However, another possibility is that the form of the gesture alone tells us that there's an object, and that it's round, that there's an agent, and that the agent released the round object. The co-occurring speech may disambiguate the gesture, but may not be required for the identification of grammatical information. So such has been demonstrated by researchers looking at non-signer comprehension of grammatical phenomena like telicity, distributivity, and phi features in unfamiliar sign languages and gesture. At the same time, the holistic view has been argued in depth for co-speech gestures, yet relatively little attention has been given to the potential structure of silent gestures, again, below the level of syntax. However, two issues have been raised. Are there elements of form-meaning pairing that persist over different contexts? And if so, where do these elements come from? So an example illustrating the first issue is due to Golden Meadow and Brentari. In an experiment they cite, a gesture produces two finger wiggling gestures. In one case, the wiggle represents the movement of legs, and in the other, it means one of two options. They use this example to argue that there's no consistent pairing between form, or the wiggling of the two fingers, and meaning. To wit, they say, to argue that the wiggling fingers gesture is composed of separately meaningful parts, one would have to show that the three components that comprise the gesture, the V hand shape, the wiggling motion, and the forward motion, are each used for a stable meaning across the speaker's gestural repertoire. In this case, the wiggle fails this requirement. Some evidence already exists, however, that suggests that elements of silent gesture are consistent across contexts, including studies demonstrating consistent strategies for distinguishing actions from objects, representing path and manner information in motion events, and of representing objects of different semantic classes, all in silent gesture. The second issue is that a form may be holistic or compositional, depending on its communicative milieu. This is exemplified by the following two productions, a silent gesture, which is on the below left, and a sign on the right. While the sign can be demonstrated to contain reusable pieces culled from the signer's lexicon, such has not been demonstrated for the gesture, despite the fact that the two forms look visually similar. To our knowledge, no study has yet examined this issue. So the two views make different sets of predictions. On the one hand, the holistic view predicts that there should be no standardized form-meaning correspondence in silent gesture, and that gestures are inconsistent across gesturers and across time within the same gesturer. It also predicts that the meaning of elements of a silent gesture come from first interpreting the meaning of the silent gesture in its entirety, and then reasoning what the parts of the gesture must contribute. By contrast, the compositional view predicts that at some level, there are consistent form-meaning pairings, and that these pairings persist within and across gestures and beyond specific or ad hoc usages. So we experimentally weigh whether silent gesture is holistic or compositional using a perception study and 2 follow-up analyses, one bottom-up and one top-down. So we chose transitivity as the grammatical domain of interest, given previous work demonstrating that this information is present in gesture production. But to be clear, here we're not looking at consistent mappings between form and lexical meaning, like wiggling fingers and walking, but between form and grammatical meaning. Okay, so to give you a little background as to how transitivity is conveyed in silent gesture, it's important to first look at how signers do it. So all sign languages studied to date have verbal classifiers, which participate in what are called classifier constructions. The movement of a classifier construction represents the verbal element, and the hand shape of the classifier construction, or the shape of the hand, is used to classify the verb's antecedent. So there are several different types of classifier constructions, but we'll just consider what are called entity classifiers and handling classifiers. So entity classifiers are intransitive and show a person moving or an object moving, whereas handling constructions are transitive and they show the manipulation of an object. In all cases, hand shape, or the shape of the hand, differentiates entity from handling constructions, that is, intransitive from transitive constructions. It turns out that gesturers or non-signers also manipulate hand shape to differentiate intransitive and transitive events, although they do it a bit differently from how signers do it. But at the same time, it's the same visual resource, that is hand shape and not, for instance, eyebrow position, that communicates this function. So it has the kind of same function. However, it's argued that hand shape use is not phonological or morphological in silent gesture, as non-signers display characteristic variability in how they represent antecedents, both within their own productions and as a group. At the same time, we'll mention that previous studies may not be generalizable. For instance, Brentarian colleagues who conducted the study only used 3 total events, and these events involved only 2 antecedents. Further, when determining whether gestures display morphological structure or patterning, they analyze hand shape as a whole, where features of the hand shape, which we'll get into later, may be more relevant. We'll also reiterate that no study of yet has examined compositionality of silent gesture directly, and few have tackled gesture of any type from the viewpoint of perception. So in the present study, we want to know whether transitivity contrasts in silent gesture are apparent to other non-signers, whether this is so across different gesturers and across gestured representations of different events, whether this ability stems from first understanding or assuming the meaning of a gesture and then reasoning that it denotes a transitive or intransitive event, or whether this ability stems from analyzing the parts of a gesture and determining that the gesture must denote a transitive or intransitive event. So to answer these questions, we elicited 276 gestures representing 46 unique events. 23 of the events denoted like transitive events, and 23 events were intransitive. And we elicited them from 6 non-signing participants. The events included, what happened? Let's see, where did we stop? Okay, can you still hear me, still see me?
Yes, perfectly.
Sorry about that. Okay, so the events included events of movement, like the toy car rolled into the box, and events of manipulation, like someone pushed a toy into the box. We annotated these gestures for 6 hand-shape features, which are relevant to transitivity coding in sign languages, which we'll discuss in a few slides. Then we conducted a gesture labeling study on Amazon Mechanical Turk, where Turkers provided 1 to 2 sentences describing what they thought each gesture meant. From this information, we could get the sentence meaning and the sentence transitivity. Okay, so the top-down hypothesis in a little more detail. So this predicts that participants' ability to discern the transitivity of a gesture is dependent on their ability to discern the meaning of the event the gesture depicts. We can measure this by first assessing how consistently participants provide transitive or intransitive sentences to a given gesture, and we'll call this the consistency of frame use. Then we can assess to what degree participants all thought the gesture meant the same thing and correlate that with consistency of frame use. Okay, so we determined consistency as follows. We collected a set of 20 sentences describing a given gesture and annotated the sentences for transitivity. We took the average and compared it against a maximally inconsistent baseline of 50%. So gestures receiving 95% transitive sentences so a gesture receiving 95% transitive sentences is 95% consistent. A gesture receiving 5% transitive sentences is also 95% consistent, but a gesture receiving 50% transitive sentences and 50% intransitive sentences is 0% consistent. Next, to determine whether participants generally assumed that a gesture had a particular meaning, we computed the semantic similarity of the verbs they used in their descriptions. Similarity was determined computationally using word representation vectors from GloVe. So similarity is measured by Euclidean distance, where similar words will have shorter distances between their vector spaces. So this is the graph we should see if the top-down hypothesis is correct. So this is idealized. For instance, consider a hammering gesture. If all participants reply with someone is hammering a nail, the consistency in syntactic frame use can be attributed to the participants all choosing the same verb. Further, if some participants say someone is hammering a nail and some say someone is pounding a nail, there's still 100% consistency in syntactic frame use, which can also be attributed to the use of similar verbs, as pound and hammer are similar. We would expect maximally inconsistent verb frame usage to correspond to very different verb meanings. If instead participants say someone is hammering and others say someone is kicking a ball, the frame consistency and semantic relatedness dissociate, which is not predicted by the top-down hypothesis. So very briefly, we use an ordinary least squares model to predict syntactic frame consistency with semantic distance. I'll ask you to hold on to this and I will describe our bottom-up hypothesis.
Can you wait for 1 second, Chuck, because the interpreter are switching?
Oh, sorry. Yep.
Yeah. No, they just went out. So just a couple of seconds.
Sure.
There you go.
Great. Okay, so as for the bottom-up hypothesis, it's predicted that aspects of how a gesture looks, specifically hand-shape features, predict how transitive a gesture is perceived to be. So we can measure this by predicting the percentage of transitive sentences a gesture elicits from the visual properties of that gesture. So again, we annotated each gesture for its visual characteristics, namely for the degree of flexion, or that's the curvature of the selected or foregrounded fingers, the degree of flexion of the unselected or backgrounded fingers, the degree of finger and joint complexity, which mark transitivity, contrast, and classifier constructions in sign languages. We annotate them also for a change in aperture, so if the hand opens or closes, and whether the gesture was one or two-handed. So here's the general pipeline for the bottom-up analysis. Again, we took Turker descriptions of the gestures and annotated them for transitivity. We took the average, giving us a transitivity score. Then we correlated the gesture annotations with the transitivity score using another OLS. So here are the results. The top-down model was significantly predictive, but the model coverage was very low. Nevertheless, semantic distance or relatedness was indeed inversely related to syntactic frame consistency as predicted by the top-down hypothesis. This means that closely related words were more likely to be consistently classed as intransitive or intransitive, or another way, participants assuming similar meanings for a gesture reasoned that the gesture was transitive or intransitive from that meaning. At the same time, there was high frame consistency irrespective of semantic distance, as can be seen in the top right quadrant of the scatter plot. That is, there was high frame consistency irrespective of perceived meaning.
You have
The other
5
hand,
more minutes, Chuck.
Oh, thank you. The bottom-up model was also significantly predictive with moderate model coverage. Additionally, 3 predictors significantly predicted the perceived transitivity of gestures. That's flexion, aperture change, and whether the gesture was one or two-handed. Thus, it appears that non-signers may use hand shape features to guess the transitivity or resolve the transitivity of silent gesture. So what does this all mean? So both the bottom-up and top-down models were significant, and thus both information streams may be relevant to transitivity resolution. However, the bottom-up model explains more cases than the top-down model. As an example, the gesture below depicts a person crushing a soda can or representing that event. Participants in the labeling study did not converge on a consistent interpretation for this gesture, providing verb labels like mold, smush, fight, and interlace. However, all of these labels are transitive, showing that the resolution of transitivity information is not dependent on first understanding the meaning of the gesture. At the same time, familiar gestures like dribbling a ball may rely on both top-down and bottom-up processing, as with familiar actions with tools like hammering a nail or cutting bread with a knife. Unfamiliar low-frequency silent gestures, by contrast, gestures like a paper airplane landing or measuring a book with a tape measure may be more reliant on bottom-up processing. However, this study did not balance potentially known and unknown gestures. So returning to the 2 issues laid out at the start, the first was concerning the variability of forms, here hand shapes, within and across different gesturers. While particular hand shapes are variable, certain ranges of hand shapes may be more relevant. For example, hand shapes with increased flexion, like those on the left below, are more likely to be perceived as transitive than those with more extended fingers, like those on the right below. This holds across 46 distinct events, suggesting that hand-shape features are used by non-signers to discern transitivity in a more general sense, beyond ad hoc usages. With respect to the second issue, where do the pieces of a gesture come from, or what combines, we suggested others do that silent gestures are reliant on constructs pre-evolved for recognizing manual actions. In some traditions, the store of gestural knowledge is even called a praxicon. The other relevant feature to the bottom-up analysis had to do with the number of hands in a gesture, where two-handed gestures were more likely to be interpreted as denoting a transitive event. We note that this is consistent with strategies employed by sign languages in classifier constructions and in lexical signs, where concepts denoting two participant events are often two-handed. The creation of new signs, or silent gestures in this case, has thus been analyzed as a structure mapping operation whereby elements of experience or perception are mapped onto the body in a componential way. So to sum up, many have argued that individual word-like gestures or silent gestures are holistic representations of their reference. However, we provide evidence from perception that grammatical information, in this case transitivity, is recoverable from silent gesture. The recovery of this information is largely not dependent on first interpreting the possible meaning of the gesture and then reasoning what it describes, and then reasoning that it describes a transitive event, in contrast to the holistic view of silent gesture. Instead, transitive information is consistently predicted from the form of the gesture itself. These elements of form are consistently used and may have their basis in cognitive domains pertaining to action comprehension. However, we did also find evidence for potential top-down processing of familiar gestures and gestures depicting familiar actions, so future studies might balance the representation of familiar with unfamiliar gestures. And finally, these results contribute to a growing literature tracking the emergence of grammatical information in the visual modality. Thank you very much.